To stand by. Conference will begin momentarily. Again, thank you for holding. Please continue to stand by. Conference will begin momentarily. Thank you for standing by. Please continue to hold. Conference will begin momentarily. Again, thank you for standing by. Please continue to hold. Conference will begin just momentarily. Please continue to stand by. Welcome and thank you for standing by. At this time, all parties are in a listen-only mode until the question and answer segment of today's conference, at which time you may press star 1 on your touch-tone phone to ask a question. I would also like to inform all parties that today's conference is being recorded. If you do have any objections, please disconnect at this time. I would now like to go ahead and turn today's call over to Mr. Joshua Finch. Sir, you may begin.
Thank you very much, Jacqueline, and good afternoon. Thank you for joining us for today's call on NASA's Commercial Crew Program and our high visibility close call review of Boeing's uncrewed orbital flight test in December 2019. Today I'm joined by Kathy Leaders, Associate Administrator for NASA's Human Exploration Operations Mission Directorate, and Steve Stitch, Manager of NASA's Commercial Crew Program. We're going to start today with updates from our presenters, both Kathy and Steve, and then we'll turn it over for media questions. So now I'll kick it over to Kathy Leaders. Kathy?
Thank you, Josh. Thank you for joining us today. We wanted to get you up to speed on where we've been on our further learning from our OFT mission. Like we had talked in the spring, we had a very in-depth review from our NASA Boeing independent review team, and when we've given you a status on where we were with that activity, very in-depth review. Over 80 recommendations that the team's been diligently working through. But at that time, my predecessor, Doug Lavero, had also realized and really wanted to make sure that we kind of had uncovered every single rock and looked through and looked at ourselves and made sure that there weren't any other organizational root causes that were out there that we could learn from to have us get ready for crewed flight. In addition, he really wanted to make sure that, you know, every mission like this is a learning experience, not just for the Commercial Crew Program, but also for the HEO Mission Directorate. And so we really wanted to make sure that we looked deep into ourselves and with our Boeing teammates and made sure that if there was any lessons learned out there that would help us and our other programs as they are also getting ready for crewed flight. And so we thank the team that conducted our high visibility close call. We put out a blog post where we kind of outlined the key things that and the recommendations that we're taking. And we will be looking at these. We already are looking at these and applying these, just as we've looked at other independent review team inputs that we've had and have applied them across our other HEO programs. And we'll continue to learn from these as we're moving towards applying these lessons learned to our other HEO programs and also to us getting ready for OFT 2.0 and moving into the critical crewed missions we have coming up. Thank you.
Thank you, Kathy. It's great to be here today to continue to talk about our progress as we work toward the OFT-2 mission with our Boeing provider. Today I'll talk a little bit about the two different things. You know, when we talked last to you in the March timeframe, we talked a lot about the NASA joint NASA-Boeing independent review team. And at the time, they had come up with 61 recommendations, which we were in the process of reviewing. But since that time, and those really dealt with the two primary anomalies on the flight, the liftoff time anomaly with the Starliner grabbing that time from the Atlas vehicle, and also the separation associated with the independent propulsion controller at the end of the flight. Since then, we've implemented a number of other recommendations dealing with the communications anomalies with what we call our forward link. And now we're up to a total of 80 recommendations that you'll see on the blog post. Those really are divided between testing and simulation. About a quarter of those are in that bracket. Updates and how we deal with requirements on the software side, about 10 of them. And then lots of process improvements. I would say the majority of the category is about 35 recommendations and processes and improvements. And then the rest really has to do with knowledge capture and software. When we spoke to you also in March, we talked about NASA establishing a review of the high visibility close call. And this is a way for us to delve maybe a little bit more deeply into some of the other issues that maybe surrounded the causes of the anomalies that we saw during the flight. Today, we can tell you that high visibility close call report has been completed. We had the team interviewed about a total of 20 plus people across NASA and Boeing to try to better understand other causes that could have led to the anomalies that we saw on the OFT mission back in December. So that report is closed out. We did learn through the team did a very thorough job, as they always do. I've been around these a number of times in my career, and they had findings in the area of systems engineering and integration, which we have within the program have taken steps to beef that area up and to better understand the Boeing systems engineering plan, and also our relationship with Boeing as it relates to how the software is developed and tested. And we've actually staffed up within the program and added a number of personnel to work side by side with Boeing as they implement the recommendations and make the software changes and then test those software changes in their various facilities. So we've added team members on the commercial crew side to be more embedded with that Boeing team and to sort of walk with them. As Boeing closes out their 81 recommendations, NASA will do the same thing on our side. We will, as a commercial crew program, sign off on every single one, and we've already started that process. And then we also have a path to implement the high visibility close call recommendations. So today we're sort of turning the page a bit from the investigation phase of OFT and moving into our hardware development. The spacecraft's coming along very well in the C3PF processing facility there at the Kennedy Space Center, and we continue to update the software. I would say the pacing item right now for flight is getting all the software upgrades in place and tested for a flight as early as later this calendar year. And I'll turn it over to you, Josh.
Thank you to you both, Kathy and Steve. And we'll now start with updates or questions from the media. So please remember, for those that would like to ask a question, you can press *1 to get into the queue. You'll be asked for your name and affiliation, and then you'll get into our queue. So we'll try to get to as many questions as we can during the time that we have. And our first question will go to Eric Berger from Ars Technica. Eric?
Hi, good afternoon. Hi, Kathy and Steve. Could one of you maybe talk a little bit about what you found when you looked at it into the NASA culture or organizational problems that led to this? Because presumably NASA dropped the ball somewhere in terms of reviewing the software that led to the errors during the flight. Were there, missed meetings? Sort of maybe give me a couple examples of how this slipped through the cracks. Thank you.
Yeah, I'll start off and then see if Kathy has anything to add, Eric. Some of the things that we looked at was, did we have the right level of engagement from the beginning? And I'll remind people that the commercial model that we're utilizing has shared accountability between NASA and the contractor, and it's always sort of had that. And we sort of use a technique of looking at what we would call high-risk areas to decide where to apply NASA resources and where to be looking for potential problems. Obviously, on a spacecraft, propulsion is one area that we've certainly had lots of oversight. I would say when we went back and looked at our culture and the way we were approaching software development with Boeing, perhaps we didn't have as many people as embedded in that process as we should have. And it's something that we've learned from. And I know Kathy has taken the learnings from this close call and is applying them across the HEO enterprise with SLS and Orion and others. So it was an area where perhaps we just didn't have quite the level of NASA insight as we should have in hindsight.
So I think this was a demonstration mission, and one of the reasons we had the demonstration mission was for an uncrewed demonstration mission was the NASA focus was in the areas where, from a higher risk perspective, where crew were involved, which was the International Space Station portion, right? And so the team, like Steve had talked about, the team focused on the areas where was there a potential damage to the crew or a high dollar item. And so these were very tough software errors and that were also not found in the integrated tests that we were assuming we're going to flesh them out, right? So this is always a tough problem for us to solve is where do you apply resources, and big integrated systems have this problem, and we have these problems where do you apply the resources to make sure that you're getting kind of the biggest bang for your buck to be able to really flesh out where you have problems in your systems. So like Steve said, we learned that there's a potential for these pretty pervasive software issues, which we thought would have gotten caught at the next level or review or an integrated test. It's what really helped us be able to go then look and say, well, why did that happen in these particular cases with this Boeing team that's obviously very skilled, has done lots of big projects, and why did that happen? And then be able to then go say, what created that happening, and then use that to then go look at our other systems and say, do we have any places where we could be using those same assumptions that prevented us from unearthing that particular software error that had potentially been embedded, many, many years ago. And so whenever you go through one of these things, it's a real huge learning opportunity for us then to look at our other processes with a new lens and just make sure that we're able to not only find the initial error, but also that we have ways through our testing and assessment programs to be able to catch the errors at the right time.
And our next question is from Lauren Grush.
Hi, thank you so much for taking the time to speak to us about this. I'm curious, now that the recommendations have been increased, how far along was Boeing in making headway in the original 61 recommendations, and how much further do they have to go to implement all of these, and what does that look like for the timeline moving forward? Thank you.
Yeah, I'll take that, Lauren, and then see if Kathy has anything to add. Boeing was very far along. As soon as the IRT produced recommendations, they started adding resources and actually implementing all of the recommendations. The ones that were added later on had to do with the communication anomalies, and so those were added most recently, and I would tell you they are already taking many steps to improve the communication system by making many changes to their software system and communication system to ensure that the same communication problems don't happen again. So they've been incrementally changing the software, testing the software, adding resources when required. They've added significant resources to add teams to go test the software, and they've laid out a schedule, to support a flight later this calendar year in terms of those software resystems. So the Boeing Corporation is very committed to finding the problems. I've seen nothing but a very solid systems engineering approach to every single recommendation, every single finding, and the appropriate resources to go work through the changes required in the software, including the testing.
And our next question will be from Marina Corin from The Atlantic.
Hi, Kathy and Steve. Thanks for doing this. On the repeat demonstration flight, whenever that happens, if that demonstration experiences significant problems too, how would you handle that situation beyond the necessary investigations? Would you give Boeing a third opportunity, or can you imagine a situation where SpaceX becomes NASA's sole transportation provider to the ISS?
Yeah, I'll take that question and see if Kathy has anything to add. I mean, right now I cannot envision a scenario where SpaceX is the only provider. I mean, the beauty of what we've done with Commercial Crew is we have two providers with two systems that they've designed very creatively, using the best talents of each company, come up with two systems. And so we need both Boeing and SpaceX to be there for us and to support crew transportation. From what I've seen of Boeing's implementation of the corrective actions, I really don't anticipate that we would be in a position to go fly. We would not get through a flight readiness review if we saw problems, systemic problems, or things that, as we see those problems leading up to the flight, we wouldn't commit to go fly an OFT-2. So I really don't see a scenario where we would get to flight and have a flight that was similar to OFT-1, just from our review process and how we're going to methodically work through every single change in the software, every single change to the hardware. And so I just really don't see that scenario as being one that would transpire. Every flight that I've been a part of in my NASA career has had anomalies. If there were some anomalies on OFT-2, we would absolutely talk about those and disposition those. But I really wouldn't anticipate us getting to flight with a situation where we would repeat the kinds of close calls that we had on the OFT mission.
Yeah, I think that, our strategy was for this, having the similar redundancy, right? And especially with two new vehicles, as you can see, we learn things with two new vehicles. And so having the SpaceX vehicle, knock on wood, we're having a very clean mission. Everything's looking well, and we're getting ready with the other missions. But we would really like to have this dissimilar redundancy as a different strategy for us to be able to then ensure that we have the capability to be able to fly our crews to the International Space Station.
And our next question will go to Bill Harwood from CBS News.
Yeah, thanks, guys. Appreciate it. Steve, can you give us even an idea when OF2 might fly if everything goes well? I mean, I've heard everything from mid-October to mid-November. I'm just curious where in there, if there's any better resolution than simply later this year. And a nuts and bolts question associated with that, whenever it does fly, how are you going to manage the ISS port assignments? Who goes where, given Crew 1 presumably will be there, CRS-21 is coming up, and, of course, OFT-2? Thanks.
Yeah, first part of the question is in terms of launch date. I really today wouldn't be able to speculate too much on when we will launch. I would say it would be toward the latter part of this year. I really want Boeing and our team to go through the software recommendations and make the changes to the software and test the software, and then once we start to see how that shapes out, we'll talk a little bit more about when to go fly. It is going to be a challenge to manage the traffic, which is a good thing for our program to have. We do need to have the Crew 1 vehicle there for the space station program for our first, what I would call an increment mission here in the fall timeframe, and then follow that up with a rotation mission in the spring. And so we'll have to kind of work through where the cargo vehicles go and how all that shapes out, and then where to go put the OFT flight in that whole sequence. And so it's neat to see that we're now building up a manifest. We're moving, as Kathy said, we're very happy with the Demo 2 test flight to date. We've got a very important part of that test flight to complete, the undocking, the deorbit, the entry and landing, and we're very focused on that as well. And then we'll see how the rest of the launches shape out the rest of this year and how to go deal with the port. It is going to be a challenge, but it's exciting to have a challenge of flying lots of different vehicles to station to support the station needs and the station mission.
As Kurt Sharman always said, he would love to have that problem, right? So we'd love to be in a place where we have too many vehicles and not enough ports. So that will be a problem that we'll have to work through, but wouldn't be the worst problem for us to have.
And our next question will go to Joey Roulette at Reuters.
Hey, thanks for doing this. Question for Kathy. I was wondering what changes to other NASA Boeing programs, like the ISS program, have been made in light of these reviews, and then also what is the scope and the status of the organizational safety assessment? Thanks.
So I think the most immediate response was making sure that we looked at really the way that the new development programs were coming on, and looking at the testing and verification strategies for the integrated, Artemis systems coming up, and looking and making sure that we had the right fidelity of test environments to be able to support and ensure that the integrated software testing was conducted appropriately. And so that was probably one of the most immediate things. Our chief engineer, NASA chief engineer, and the HEO chief engineer actually sat and did an assessment with the chief engineers across our mission directorate, and kind of had them going out and looking at all the testing, integration and testing regimes that we had, and just making sure that for especially development of new systems, that there weren't any areas where they thought we needed to beef up based on our understanding of what we learned out of the system. For the organizational safety assessment, we're still planning. This is on doing an organizational safety assessment with Boeing. That plan's been in work. We had done one with SpaceX, and we were planning to have a follow-on with Boeing. But a key part of the organizational safety assessment is this face-to-face interview process that's very in-depth for us to kind of collect data with individuals across the team. And so in the COVID environment, obviously, where we were planning on starting this in the late spring time frame, that team's really been on hold and trying to figure out how to get the value of the assessment, but understanding the health restrictions that are there. And so we're kind of waiting to see when's the right time to be able to do that, understanding that we did want to have that assessment done prior to us moving into a crewed flight with Boeing.
And our next question is for Stephen Clark at Spaceflight Now.
Hi, thank you for taking my question. I had a question on the communications issue that sort of was identified that prevented stable comm link with mission control. Did you ever identify what the cause of the interference was? I think there was some talk about it occurring over specific geographic areas. And just the statement, the blog post references an RF filter to sort of reject interference. Can you talk about what exactly that will do and what other corrective actions you have planned for that problem? Thank you.
Yeah, I can talk about a little bit about the comm problem. So as we started to look at the data from the flight and why we didn't get a good forward communication link with the spacecraft, what we found was that the system perhaps allowed a little bit too big of a band of frequencies to come in to the transceiver itself. And so what Boeing has done to fix that and mitigate that problem is actually install a filter, which essentially only allows the receiver to listen to a very narrow band of frequencies with the tracking data relay satellite. That filter has been tested at JSC in our engineering systems test lab, and that filter is panning out very well. They've also made a few software changes to optimize the way the spacecraft points to teeters. Essentially, it has a series of antennas around the circumference of the spacecraft, and so it sort of optimizes those antennas to look more upward to the teeter satellites and versus looking kind of down toward the Earth. A lot of the frequencies that can interfere with comms sort of come from the Earth below, and so they've optimized the software to do that. So they've made a couple of changes in those areas, and so we think we have a good fixes for these two problems. So.
And our next question is from Tim Bernholtz at Quartz.
Hello there. Thank you for taking the time to do this. I just had two quick follow-ups on the HVCC recommendations that are in the blog post. On the first one, it says it requires the systems engineering management plan has specific requirements. What requirements were missing in Boeing's plan? And it also says ensure NASA IV&V teams provide insight to contractor IV&V agents. What insight was not provided to the contractor? And then just for Kathy, I'm just curious, we often hear, and we said it today, that officials observing that Boeing is a big company with a lot of experience. So obviously they know how to do this stuff, and we know their history with NASA. But I'm just curious at what point we need to sort of rethink those assumptions given recent performance. Thank you.
Yeah, I'll take the first question. I don't recall. We'd have to go back and look. I don't recall exactly what the details were for the requirements that weren't called out in the contractor management approach. I know we're going back and looking very carefully at their systems engineering management plan and making sure they comply. So I can't. I apologize. I can't answer that question.
Hey, Steve.
Yes. Okay.
So the strategy was that originally, because we're buying a service and the capability, NASA did not have a requirement with the contractors to provide a systems engineering management plan that kind of laid out what their systems engineering structure was. And what we found out was that if we would have understood what that structure was, we would have been been able to plug into their kind of decision-making process for how they were performing that SE&I function. And so it was a place, and we go back and forth on this, on, what's the value of having an SE&I plan and not having it. When we were starting the commercial crew program, there was, we were really trying to kind of streamline the requirement sets, and we found out that this would have been, having that plan would have helped us better understand what their strategy was for laying out an SE&I approach, in particular for how they were integrating their software and hardware integration pieces together. And we thought we understood it, but we ended up finding out that over time it kind of had changed, and with this plan it probably would have been more obvious that things were changing for us to do it. So it was just a lesson learned from us after the fact that we said if we would have had that, it would have been more obvious for us to have been able to see when their approach changed. And on the IVMV side, there was a requirement. It's just more about, we had oversight into how they were doing their IVMV plans and what their contractors were doing. But we felt like we needed more insight into the reports and the areas that the IVMV contractor in particular was focusing on. And so it's one of those areas that Steve talked about, that they added additional resources to get more insight into that particular area.
Yeah, the independent verification and validation, basically we have required both Boeing and SpaceX to have an independent contractor look at the software with a different lens. They can run different test cases than Boeing or SpaceX would run. And we have strengthened our insight into that because we think it's very important to have our team look at what the independent contractor is running so that we can better see across the whole software suite what parts of the modules have been tested. And I can say for the Demo 2 flight, we actually did go through that independent verification and validation for the third-party contractor and look through all their test cases, and we're doing the same thing with Boeing as we move toward OFT2.
I think to answer the last question, I think, Boeing also is changing how they're doing business too, right? I think this is a place where both Boeing and NASA were learning together about doing business in this new way, right? And so this, the team that went out and reviewed and talked to folks, talked to not only the Boeing side, but also the NASA side. And coming out of that, both sides realized that if we're going to be operating in this model, we do need to change our assumptions and how we're working together. This was a different model than us having a cost-plus contract with Boeing. And so because of that, and it's just something that in the future, our relationship was different. And we probably on both sides needed to change how we adjusted to each other. And I think that's going to be real learning that we can take forward into our human lander system programs and other programs, that as we're working and learning how to do and working with companies in new ways, that we are going to have to adjust and adapt and figure out how to do our NASA insight and oversight in different ways to be able to execute on really, really tough programs.
And our next question is for Marcia Dunn at AP.
Yes, hi. I'm wondering if you could compare the amount of pre-flight oversight to the Starliner versus the amount of attention paid to the SpaceX side. I'm just wondering, in retrospect, do you think NASA had so much of its resources focused on SpaceX, since it's the newcomer, that it led to less oversight with Boeing, given that it had been around for so long?
Yeah, I'll take that, Marcia. It's a very good question, and it's a very introspective question that we tend to try to ask ourselves all the time when we're working with both partners. Are we looking at the higher risk systems on each vehicle consistently? I would say in the area of, first of all, across the board for each mission, I think we've done a really good job of looking at all the higher risk areas and trying to focus on things that would be really detrimental if they happen in the flight. I would say in the software area, from a NASA perspective, we may have been focused a little more on SpaceX because they use a bit of a non-traditional approach to their software development in terms of maybe a bit of a spiral development. They have requirements, and then they code to the requirements, and they do unit tests, and they do all the kinds of typical software testing, but they maybe do it in a kind of a spiral development approach, which many aerospace companies do these days. And so we may have had a few more people looking at that. And then we were, I would say, a little more used to the Boeing process. It's one that we have used in the past in successful NASA programs like Space Shuttle and the International Space Station, where you lay out all the requirements for the software and then you hand them to the software team. And then they implement those requirements, they test them at kind of a module level, and then as they integrate modules, they test them. And so perhaps we were a little more focused on SpaceX. I think we've now looked back across both companies and tried to balance the portfolio of people we have. We've certainly added resources to both software development on SpaceX and Boeing, just to make sure that we have that covered, because we now understand the importance of that software. These are complicated spacecraft with launching, landing, and then they do ascent aborts, and they do aborts as well close to the space station. So we've augmented resources on both partners to make sure that we're covered.
Our next question is from Keith Cowling at NASA Watch.
Hi, thanks for y'all doing this today for whoever wants to answer. A bit of a follow-up. You only discovered that you had a major problem with Starliner after the vehicle was actually in flight. So, as has been mentioned in your report, obviously the process with NASA and Boeing failed in this regard. Yet things like this didn't happen with SpaceX, and I'm just wondering why the SpaceX process with NASA worked so well when it didn't work with Boeing. Now, I just heard a bit of a description of how it might have happened, but shouldn't you have a process that's kind of the same for both contractors, or are they really that different from each other in terms of how they approach the joint things? And given that you've got at least a better working relationship with SpaceX, should some of the lessons learned from the NASA-SpaceX relationship be applied to the NASA-Boeing relationship?
Yeah, wow, there's lots of parts to that question, Keith. I'll start, and then I'll let Kathy jump in. I would say I would like to start with the last part first. In terms of relationship, I think the relationship is very solid between the commercial crew program, our engineering team, our safety team, our flight ops team, and both contractors, both Boeing and SpaceX. We have tremendous insight into everything that they're doing and all the different problems and anomalies and testing that goes on. So I think we have a really good relationship. I think in this case, we perhaps, when one provider has a newer approach than another, it's often natural for a human being to spend more time on that newer approach, and maybe we didn't quite take the time we needed with the more traditional approach. We had maybe more familiarity with the Boeing process from those that had worked on the International Space Station. Many of the team that did the software for International Space Station was actually working on the Starliner, and so we just didn't quite take the time that we needed to. In hindsight, these high visibility close calls and these investigations, many times I've seen it over my career. It's a little more obvious afterwards than when you're in the middle of it. And I think we've sort of learned that lesson, and we're applying it equally across both providers. We're looking across multiple systems on the vehicles, whether it be the launch vehicle, the launch pad, the control centers, to see if we have any other gaps. I think one of the things that these close calls do for you, and Kathy talked about that for human lander systems, it's a bit of a wake-up call for NASA and its contractors. And I would tell you, all the contractors were interested when the anomalies happened, when we had the IRT. They all want the lessons learned, because they all know that this business is really tough. The systems are complicated, the software is complicated, and it doesn't take much to have something that can cause, mission anomalies like we saw during OFT2, OFT.
But Keith, we also, we've learned, and I think that's where having a program like Commercial Crew Program and the Human Lander Program and being able to learn off of that, I feel like we got this huge blessing here because we're able to work with all these different approaches. One of the things we did learn is that the SpaceX approach actually has a very robust way that after your software is done and tested, they go back and ask the particular engineers, the responsible engineers, hey, is this system operating the way you want it to operate? And they sign off on it, right? And that's something, honestly, that looking at it, we all said, hey, that's something that we would like to see more of, not only in the particular Boeing application, but across the board. It's having this very strong systems engineering approach between the guys and gals out there designing the systems and then making sure that, hey, the software, those software people are kind of strange over in the corner and, kind of viewed as a service. But as we know nowadays, your system is very integrated. Your software capability really drives and the capability of the overall system. And so this is a big systems engineering learning for us, is that we need to really go look at how and making sure that the owners of the systems understand how the systems actually operate and that they kind of own and understand that function. And it's something that honestly we on the NASA side implemented prior to Demo 2, was going back through, even on the NASA side, having folks go through on the NASA side and make sure that the NASA system managers that were looking at the software, that they understood how the SpaceX folks had implemented in their systems that they were responsible for. So this has been a big learning experience for us. I tell people, and people get tired of hearing that, and that this was a gift, but this is helping us develop more robust processes, thought processes across the mission directorate, and then be able to provide that learning to through the joint contractor NASA team for us to continue to apply these lessons to our further and future success on the tough missions we have going forward. We are taking this learning, we're applying this learning, and it is helping us.
All right, and our next question is from Irene Klotz at Aviation Week.
Thanks. Good afternoon. This is a first part is for Steve. Aside from looking at the third-party independent verification and validation for Demo 2, is there anything else specifically stemming from the orbital flight test investigation that has spilled over into the SpaceX arena, or anything that you see coming up for bringing on Sierra Nevada and bringing on Axion and some of these new companies that are going to be participating in the NASA's LEO program?
Yeah, I can address that. I would say when SpaceX had heard of the anomaly, even during the OFT mission, they, began to contact us and ask questions about what, if anything, they could do to prevent this from happening on any of their flights. And I think in the aerospace industry, all of the companies are sort of in it together, and they all understand how tough it is. And so all the companies, Sierra Nevada, Axiom, and others, are interested in learning from this particular anomaly. With respect to SpaceX, I did talk about, hey, we did go more thoroughly review the independent validation and verification for Demo 2 prior to that flight. It was one of the things that we did in the May timeframe to make sure that the software was ready to go. We very thoroughly talked about every software change that was made, even small parameters in the software as we built up to that flight. And then SpaceX took it upon themselves to run, I think, extra test cases between the launch vehicle and the F9 and the Dragon, just because they knew, they were familiar with what had happened in terms of the Starliner anomaly and the Atlas. And then also for Demo 2, it was the first time we had the escape system enabled with a crew on board. And so they ran lots more cases, I would say. And, we see the same thing from Boeing as they work toward their crew flight. I know the plan for OFT2 is to begin to have the abort system enabled, and they're starting to run extra cases for aborts as well as they work toward their crewed flight test capability.
Thanks. And for Kathy, is there any direct tie-over from this investigation for SLS ground systems and software?
So I think, like Irene, like we talked about before, the SLS, there's not a unique tie because it's another Boeing system. But what the teams have done through the chief engineer review has gone through and said, obviously this was a place where where we had problems was across kind of interfaces, right? And so understanding that the Artemis system has many interfaces, we wanted to make sure that across the SLS vehicle itself, we need to make sure we're fully testing all the interfaces. Obviously, with the integrated vehicle with the Orion on there, we want to make sure that we don't have a particular spacecraft to launch vehicle issue again. And so it did give us pause and then a particular action to go make sure that there are not any kind of hidden gotchas out there for us across those what are very critical interfaces on the Artemis system. The SpaceX folks have had the advantage of flying for 10 years. It's one of the huge things, and with being able to do the cargo missions and building up to the cargo missions. And so what's great about this new fleet of vehicles coming on board is that the lessons with the folks that are flying then can be handed over, and we're very grateful that Boeing and also SpaceX, as they've worked through lessons learned on their accident, that they're able to share that with this aerospace community, because this is a community we're dependent on, and we need it to be as safe and robust an industry as possible.
Thank you.
And our next question is from Paul Rivera from West 2 News Orlando.
Hey there, thank you. Wanted to know, how much will this review sort of hang over and keep Boeing in the current backseat to SpaceX for future chances to go on history-making missions? Good, and that's just to whoever can answer.
Yeah, I mean, Kathy may be better to answer the question than me, but from my perspective, every aerospace company goes through these, I think Kathy said it very well, gifts, where you have an anomaly and you learn from it. And, years from now, we will remember the learning and get into routine flights, including increment missions with Boeing, and we'll have both Boeing and SpaceX regularly servicing the space station, taking our astronauts back and forth and serving as a lifeboat, just like we need them to do. I think years later, these kind of things disappear. It's a big thing now. It's a big thing that we're all talking about. But years from now, I don't think it really will factor in. I know Boeing will take every recommendation to heart. They're going to become a better company because of it. What you typically see in aerospace is that anytime a company has an anomaly like this, they work to become better, and it will not only improve this product line in terms of Starliner, but it'll move over into to SLS and other product lines for the future, because these lessons learned are hard lessons learned, and we were fortunate to have a successful test flight and get the vehicle back. And I'll remind everybody the entry software, which is an extremely complicated part of the flight, worked flawlessly. So I think companies just tend to learn from these things, and then they put things in place such that it doesn't happen again, and they'll look at themselves very toughly and make improvements so that they have a better product for the future.
Yeah, I think, we tend to focus, and we're focusing on here's the places where there's problems and what we're doing to fix it. But we're not focusing today, but that there's 2 spacecraft getting ready in Florida right now, right? There's a launch vehicle there ready to fly. This is about tweaking the system, right? This is about tweaking the spacecraft and tweaking the software to make sure that these particular errors that we found are fixed, right? We're able to, like Steve said, we're able to get the spacecraft back, and it's in the process right now of getting ready for our crewed flight test. And they're making progress in getting the orbital flight test ready. We got 2 spacecraft in the C-3PF right now. So we are making progress and doing the next steps to go fly with Boeing next year.
And our next question is from Thomas Burkhart, spaceflight.com.
Hi, thank you for holding this press conference. Thomas Burkhart from NASASpaceflight.com. My question is, if the reflight of the uncrewed orbital flight test goes well, what kind of turnaround time is NASA hoping for or expecting for the crewed flight test? And how will that crewed flight test align with respect to the SpaceX Crew 1 mission? Thanks.
Yeah, Thomas, obviously the path to crewed flight is through a successful orbital flight test 2. It's sort of hard to see the timeline between the two. Right now, one of the great things Boeing is doing is the software that they're going to go fly on the uncrewed flight test OFT is exactly the same software they're going to fly on the crewed flight test. So we'll get a good ring out of the software. We'll get a good ring out of the docking system on OFT2, leading to a crewed flight test. As Kathy said, they're working through processing 2 vehicles. One that's returned from space, what's called spacecraft 3 for CFT, and they've got to go work through that. It's the first time they've refurbished a vehicle, so there's really a couple of aspects of getting ready for CFT. One is this refurbishment process on the spacecraft 3 vehicle, and then also getting the software in place for OFT2 and also for the crewed vehicle. So there's a couple of different swim lanes, if you will. One's the software swim lane, the other is the hardware readiness. So right now, looking at a flight in the spring next year in the spring time frame, first quarter spring time frame, we'll have to see how that all shakes out as they get the software ready and they continue to refurbish the vehicle for CFT.
And our next question is from Kenneth Chang, New York Times.
Hi, thank you very much. This is following up on the earlier question about if Boeing encounters another major problem. There was a third company that had bid on commercial crew, Sierra Nevada, and they subsequently got the CRS-2 contract for a cargo version that maintains a lot of the human rating. So if Boeing has another problem, has there been any discussion among yourselves or perhaps with Sierra Nevada about perhaps being able to revive a crewed Dream Chaser as a backup?
Yeah, that's a good question. The Commercial Crew Program has had a long-term relationship with Sierra Nevada. We continue to talk. They have aspirations about taking that vehicle and making it into a crew capability for their own purposes. It's something that is part of our goal as Commercial Crew, is to enable other companies to go take their vehicles and have a crew capability. We have not entertained any discussions at this point of using the Dream Chaser as a backup to Starliner. We're working hand in hand with Boeing to try to get the vehicle improved, to improve the software, improve the testing, and get that capability. fielded and have a crewed flight test next year, and then get into these regular missions with the International Space Station. So we really haven't had any serious discussions at all about on-ramping the Dream Chaser. We like the Dream Chaser program and continue to have a relationship with Sierra Nevada in terms of some of their own corporate goals to field a crewed spacecraft, but we haven't had any serious discussions at this point of replacing a Starliner capability with Dream Chaser. It's just not something we've done.
Our next question is from Gina Sinceri with ABC News.
Yes, what test objectives would you be adding to this next test flight later this year?
In terms of the on-orbit flight test 2, it has many of the same test objectives that the first flight has. The main part of the flight that we did not get to test was getting into the arena of space station, into the approach ellipsoid, and executing the Vesta system and checking out the rendezvous and docking. And really, that's a key component of the flight that we would really like to check out. It would be the first time we've tested the NASA docking system, which the Starliner employs the NASA docking system. So those are the main objectives. I mean, if you looked at the two flights side by side, they will look very much the same in terms of the objectives to test. Some of the systems have been upgraded slightly, I would say, from where they were on OFT, the first OFT mission, in terms of maybe having hardware a little more mature for a crewed flight test. But other than that, the missions will look very much the same. And the objectives is really to dock with the space station safely and test out that rendezvous and docking system, and in particular the NASA docking system.
And it's going to be really great that we're able to have this mission then that's really checking, that's going to be verifying the effectiveness of the upgrades, right? In particular in the comm area and some of these other areas prior to going into the crewed mission. That would have been a trade that we would have had to check, and because in particular, a lot of these are things, that's why you do the demo missions, right? To be able to check out on orbit the things that you can't check out as well on the ground. And so, these new upgrades that the Boeing and NASA team is working on, it'll be really great to see them, be demonstrated on our OFT 2.0 before we're heading into our crewed missions.
Our next question is from Dave Mosier with Business Insider.
It's my attempt to sort of take a big step back with a procedural question. So a new NASA release says the full list of recommendations is company sensitive and proprietary. I guess my question about that is, do you plan to release a full but redacted investigation report as was done with the EVA suit water intrusion close call in 2013? And if not, what's the rationale there? Would that not run up against many years of transparency about significant issues? And also, wouldn't it, just practically speaking, wouldn't it help other providers, current and future, catch similar or sort of related flaws and improve their overall safety by sharing that stuff? Thank you.
So we've been struggling with how to do this. I'm going to tell you, we don't have the answer yet, Dave. We're actually providing you with the findings and the recommendations, but this is also a place where we're trying to protect, the specific proprietary data that the Boeing folks have. And so we are trying to give you the data that we feel like most pertains. It's something we've been struggling even within NASA, and honestly spent a tremendous amount of time trying to figure out ways to be able to have the right discussions with SpaceX and Lockheed and the myriad of contractors out there for folks so that they can all get to the lessons learned. It's a hard problem. So we right now, if we give you a redacted version that isn't very helpful, that's not going to really help people either. So I don't think we've solved that problem yet. But what we are trying to do is to tell you the items that we can without impacting the proprietary nature of the specific solutions that the Boeing folks have. We also want to make sure that in the future we can have this open conversation between us and our providers, so that we can ferret out issues without them being worried at the end of something being put out there that they have issues with. So we're really struggling with how to be transparent and letting you see the pieces, but want to make sure that in the future, when we have these activities together, we're not going to do something by putting out a report that then prevents open and honest conversations through our programs together.
Thank you.
We have time for just about 2 more questions. Our next will go to Hanukkah from space.com.
Hi, thank you for taking my question. So this is for Kathy, since you said earlier that you want to make sure that every mission is a learning experience, not just for commercial crew, but also for HEO. I'm wondering what you think is the #1 most important lesson learned from OFT that can be directly applied to future crewed missions to the moon? And also, has the whole experience led NASA to implement any changes in the way that the agency is preparing for Artemis now?
So I think that the 2 things that I really felt were really huge takeaways were this making sure you understand across the interfaces how we're really checking the assumptions that people have made about the interface from both sides, right? Especially when it's a very, very, very complicated system. And are you making sure that you have really tested those interfaces with the right test environment and the right fidelity of that test environment to make sure that you really have done that testing. I think that was a big takeaway from us across the board. And where those assumptions were on the interface is why the SDNI piece is so important, because typically across interfaces is where you need that SDNI function to make sure that you have those linkages and the understanding across those interfaces. So that's a huge lessons learned for us. The other thing is making sure as we're working through the relationship with each other that we're understanding which part of this the other parts of the team are doing. So I use the example of, making sure your hardware owners understand how their software folks have implemented capability within your systems, and then making sure that you're going back and you understand that, and then make sure that it's operating the way you're doing it. We're kind of breaking down how we've done things and developed things in silos, and we got to make sure that for these very complicated systems, we're breaking down the silos and making sure that we're really understanding how our integrated systems work together.
And that's all the time we have for today. I would like to give Kathy a chance for any closing final comments before we end the call today. Kathy?
So I'm going to tell you I'm very proud of the team. First, the NASA and Boeing independent review team. I mean, they really looked hard at themselves and made sure that they felt like they were identifying all the key issues that need to be fixed before heading into this next mission. But I'm also really appreciate Ronnie Rodriguez, who was the lead for our high visibility close call team. He also came in, looked at it. We needed to make sure that there wasn't anything else out there from an organizational perspective that also contributed to the close call. And so I appreciate all the work that team did. They met their delivery date. They gave us some really meaty things to go work on. And I'm positive that Steve and the Boeing team now will be applying those and moving that towards us having a successful OFT-2 mission coming up, and even more important, a successful crewed mission in this next year. Thank you.
Thank you, Kathy and Steve. And for everyone joining, you can listen to a replay of this teleconference by dialing 888-568-0182. That number again is 888-568-0182. Thank you, and have a good rest of your day.
Thank you for your participation in today's conference. You may now disconnect at this time. Thank you for your participation in today's conference. You may now disconnect at this time.